welcome to the Qubit Guy podcast, brought to you by Classiq, the quantum algorithm design company. My name is Yuval, and my guests today are Marcin Detyniecki, Head of Research and Development and Chief Data Scientist at AXA, as well as George Woodman, Quantum Computing Lead at AXA. Marcin, George, and I discuss what enterprises are looking for when they get into quantum computing, how Marcin and George build support within AXA, and much more. We hope you enjoyed this episode. Please let us know how we did by emailing hello@classiq.io. That's hello@classiq.io. Hello, Marcin. Hello, George. How are you doing today?
Oh, thank you very much for having us.
Yes, thank you. Thank you very much. Feeling great.
So who are you and what do you do?
So, George, maybe you start.
Yes, okay. So I am the quantum computing lead at AXA. AXA's, if you don't know, is one of the leading insurers in France and the world. And I run their quantum computing project to try and see where we can use quantum computing within the insurance business and how it's going to impact us, try and gauge the timelines and make people aware within the business that this technology could be on its way.
Yeah, and I'm Marcin Detyniecki. I'm the chief data scientist of the group, and among my jobs, I'm responsible for the R&D part, and this is how I'm involved in quantum.
Excellent. And I saw a presentation that the two of you gave in 2019, so I suspect you started quantum before that. When did you start? When did AXA start with quantum, and what got you interested in the first place?
Yeah, so I think we started a little bit early. Like I would say maybe 1 year earlier than that. And why did we start? I think if you think about quantum computing, we know it's kind of mathematically proven that this is going to disrupt our world, right? Classical world. If you think, let's say, something like a Shor algorithm and prime factorization, right? And this is what we're able to do something we were not able to do before the prime factorization, and this is disruption, right? So now we are AXA, we are a great, very large insurance company, and our work is to think about the future and prepare for that future. So in particular, if there is some sort of disruption, we need to kind of get prepared. So quite naturally, we decided to prepare for it. So what I think makes our preparation unique is that we invested time and effort to really understand the technology. I mean, it was not just about kind of like trying to figure out, oh, this is nice use case and so on, but really, really going deep into understanding how does it work, how the mechanisms, how we can program the machines and so on. So this is a particularity. And if you think about it, it's very fundamental, because quantum computing, for somebody who is far away, may think that this is just the next personal computer, like the next generation, but it's not, right? It's not, because its nature, which is associated, it's very strongly associated, for example, with the way you program it. I mean, if you design circuits, it's very different of object programming languages. So really, we invest a lot of time into trying to understand the fundamentals. And also because I think that this technology is very, very good from some very, very specific problems and use cases, and not for others. I think this is what it makes our trip a little bit different.
Now, quantum computing in the financial services industry has a lot of different use cases, right? From risk analysis to portfolio optimization and credit risk and what have you. Is there a particular use case or use cases that you found are interesting to AXA?
I think I'll take this one. So I think a majority of our work over the last 2 or 3 years now has been to find this use case, because finance, of course, has lots of interesting use cases, as you can see from all the publications that are coming out of all the big investment banks. But there's been less activity from the insurance side. And what we're trying to find is, going through the different types of technology. So that's including annealing and gate-based quantum computing, and trying to figure out what are the small, because, it's not going to solve the entire problem. It's trying to find the small parts of a big problem that we believe quantum can be solving in the next, 7, 10, 15 years. Part of that is, of course, risk analysis and the Monte Carlo speedups that are hopefully potential, but then you get more optimization-based problems that could have a shorter timeline based on how the technology grows and which technology we are going to use. And then we have to look into how the improvement in the technology affects just our customers. So we don't do pharmaceuticals, but our customers do, and that could affect them. And we need to keep them informed about that because that's the technology that's probably going to progress the most, the fastest, and they need to be aware of that. And there are certain other areas like that that we think that quantum could really be used for. But I think we're trying to keep it as trying to be realistic with the technology, because I think there's a lot of overhype from maybe the technology providers, and then I think we try to give them a good baseline, not to oversell the technology, but so that our business lines understand when it's going to be available, and that this process is going to take a long time. The use cases that we're going to build are going to be very small at the start, and they're going to grow at a slow rate until you reach that quantum advantage stage in however long that's going to be, and then hopefully by then you can really take off and prove how good quantum can be. But it's going to be a long way.
One of the challenges that I think organizations have, where new technology comes in, but then you have to sell it to the business units. You have to get organizational buy-in. Otherwise, it's just two guys in a room doing something, and no one will ever know. What can you share from your experience at AXA that might be relevant to other people who are going into quantum and saying, how do we get organizational buy-in? What should we do? What should we not do to get this going in our companies?
Yeah, maybe George, you can comment a little bit on what we're doing with our internal communities.
Yeah, sure. So I think it's really good I know quantum computing is quite a confusing. It's got a steep learning curve at the start, but I think if you get over that curve with maybe a few technical people that do have access to all of these use cases and teach them what the potential of quantum can do, and also keep them aware of how the technology is growing and be realistic in expectations. And I think that would mean that the future for that use case can be very profitable. But I think it's creating this internal quantum computing community where people, like lots of different people, are interacting with each other with different quantum levels of quantum computing knowledge, so that they can work together to prove these use cases. Because we found the hardest thing to do is to find the specific use cases that quantum computing can be used for, because there's all of these algorithms that are coming out, all the technology advancements, but aligning them all together and finding the technology that's not only going to be useful in like 10 years, but also is going to have a big impact and is scalable from now, is something that we've battled with a lot. And I think having an internal community of 100 stakeholders with various backgrounds in the business can really help grow that and help.
How close are you to something in production? Where are you on the quantum journey, from understanding the technology to building a couple of simple circuits to prototyping to actually something that would be deployed in production?
So I think the deployment in production is a hard thing to gauge, because you don't want to produce something in production if it's not better than its current classical counterpart. We have done a few, say, proof of concepts of certain areas of where we think quantum could be useful, but they've always been quite small toy models, and then we're waiting for the technology and the hardware to improve so that we can build that into a production environment that we can prove is faster than what we're currently doing. But a lot of the areas that we're looking at, the calculations that we need to be doing are just so massive. The technology that we're requiring is, I don't like to gauge quantum size by qubits, because there's so much more to a quantum computer just by the number of qubits. But it's the easiest thing to gauge, and the qubit numbers just aren't there at the moment for the size of the problems that we want to be working out. We do have proof of concepts and ideas for, and as the algorithms change as well, we're keeping up with those, and hopefully they can bring forward that timeline and that point that we can actually start deploying them and not just using them as a research project. But I still think it's a number of years away until production-based environments are going to be affected by quantum. And when that does happen, there'll be lots of other because at the moment you're just working on the cloud on like a pay-as-you-go basis, but at that point it might need a bit more of a serious conversation with how it would work.
I have a hypothesis on what companies want, and that hypothesis comes from both speaking to a lot of companies as part of my job at Classiq, and also because I interview a lot of fascinating people on the podcast. And so I want to ask you a few bullet points, short answers, if you think it makes sense. I mean, maybe I've got it completely wrong, and so this is my opportunity to learn from the experts. So I think that when companies get into quantum, the first thing, or not the first thing, but an important thing for them is to build internal competency. So they don't want to say that they say quantum is just too important to outsource everything to a consulting group. Do you think that's a fair statement?
Yes, I think, not to jump in too much, but I think that because it's such a complicated technology, you need to internalize some of that knowledge, because all of these consultants or technology companies might be coming with all of these hopes that technology, is going to break the world in 3 years, and you need to put the ground truth down and be like, no, this is actually what's going to happen for us, and not just leave that up to an external provider.
Perfect. And so the other thing I think people want is short prototyping cycles. So you've identified a number of use cases. Maybe you want to do proof of concepts. It's probably better than a proof of concept takes 2 or 3 months and not 2 or 3 years. You think that's a fair statement?
Yeah, I guess
Yes.
everybody wants to have short. Everybody wants to have short cycles. I don't know if it's always the feasible, but yes, that's what you want to do. You want to have go through things and try to get it done. I mean, I think the most important part of your hypothesis is to get it done. It's not that much the shortness. I mean, it's of course you try to make it short, but I think it's more to make it without I mean, even releasing some difficulties. So for example, making it a toy instead of trying to wait for 3 years to make it the full size. So yes, it's a cycle oriented, but yeah, so you see the spirit is a little bit different. Just to think, yes, of course I want short cycles which produce money at the end of the day, right?
Okay. And to George's point earlier, how important is it when you do the proof of concepts to choose algorithms that scale? So you can say, okay, today I have 20, 30 qubits, I can do this and that, but this algorithm, once computers are with 2,000 qubits, I can use something very similar on a bigger computer. How important is to choose something that scales, in your opinion?
I think there's two sides there, because obviously you want something that scales, but also a scalable algorithm might not have the same impact that a non-scalable algorithm that has a larger impact at like a lower level. And you want to, we are still a business, and to sell the technology to the stakeholders, you need to prove that it's working. So I think there's a lot of balancing between proving something that could potentially work now to something that could potentially work in 10 years but won't work now. So I think a good analysis of that would be between like annealing and gate-based. So annealing is more of a realized technology. The actual like hope as if it would be have quantum advantages still up for debate, isn't it? But that is something that you could potentially show now to like a director and be like, look at this amazing thing that you can do. Whereas if you say try to do a Monte Carlo simulation with an algorithm and try and show that to director, that where you're only running it on like three or four assets, because so much of the other is put into error correction or like just holding the qubits, then I think it does need a balance between the two. obviously, and also because the research it's perpetually, these algorithms are getting improved upon by all of the software and the algorithm companies and the universities and like the technology companies. Like the algorithms of today are definitely not going to be the algorithms of 7 years from now. Maybe like, Shaw, or well, there'll be the Grovers and the Shaws, like the foundations, but the actual algorithms that we're using at the moment will be potentially different because of how the technology goes. And also, I feel like, you know how you get superconducting ion Q, trapped ion, silicon spin, all the different kinds of technology. Which one of them is going to come out on top, or are they all just going to branch off into their own, because they all have pros and cons, and which one's going to improve? And some do better with some algorithms than other because of, their decoherence times or like the fabrication, or the ability to scale them up. I think there's so many different factors into choosing which algorithm is best for a certain problem. And then putting that to say 10 years in the future is difficult.
And that leads me perfectly to the next to last point in the hypothesis, which is hardware portability. So let's put aside annealing.
Mm-hmm.
And as you mentioned, there are many gate-based approaches, and organizations that I speak with are saying, well, we're not sure if IonQ is going to win, or Honeywell, or IBM, or PsiQuantum, or whoever. I mean, I like everyone. But how important is it for an organization like AXA to say, we don't want to write the code in such a way that it only runs on one gate-based machine?
I think this goes a little bit. It's very much in relationship with the previous question, right? Because it's you're focusing very much on one dimension of the problem, which is the scalability. So I guess that I think more important than use scalability, and it was mentioned by George. It's I think the fact that this matches a real business problem. Okay, that's really a thing. Okay, because in some sense, quantum computing is extremely promising, but it's not delivering, let's say, the full expected value yet, right? And we're at early stage, I understand, but you need to find this use case, and I think the community in general is very much focused on the technology, not enough, I think, looking at the business problem. The business problem is very, very tricky, and this will answer your question, right? Because it's very tricky, because you need to find the exact place of your problem in which you can make it happen. And since it's not full-fledged, let's say in terms of size or memory or whatever, then you need to find a problem which is kind of the right size, the right problem, and fits your process and has a big business problem. So if you are very close to that, okay, so let's say you do trading, okay, and you're very close to that, and you have an option call kind of problem, and you're really close, then you can be very specific to one technology, right? Because you're very close, then you want to optimize this very specific architecture, and then you get this 1 year advantage, let's say, okay, and if your problem is a little bit more far away in time, in that case, what you want to do is to be generic. So I would say us, we are more closer to the more generic kind of a thing approach, because we have not identified use case where we are really kind of around just about to put in production, where we need to kind of squeeze the thing and exploit the specificities of the technology. So yeah, so that's I think really that we're underestimating, or let's say the community in general is underestimating the difficulty to nail the business problem.
And in that sense, and that really brings me to the last part of my hypothesis, is that it's really important to be able to integrate experts that are not quantum experts. So experts in trading, or experts in life insurance, or experts in chemistry, depending on the business problem. I suspect you agree with that.
Yeah, absolutely. I mean, and George can tell you, I mean, this is really, we spend a lot of time. The difficulty is to kind of convince the people that you need to invest now for something that it's not proven completely yet that this is out there. So all these expert or business experts, they have short-term kind of, missions and results and objectives. and the whole challenge is kind of to bring them and tell them like what is the potential of this technology, so that yes, they work together. And it's really, as I said, it's not just one dimension, the technology, the scalability, the architecture. It's really everything to make it happen.
So I was really happy that you agreed to come on the podcast because I want to bring interesting content to my listeners. But I'm curious, what did you or what do you want to gain from being here? What would you like to gain from this podcast?
Well, of course, we're very honored to be back, to be here. I think for me, I think it's really important that because the technology is such an early stage, that there's not too much of a competitive advantage for an external ecosystem. So, say other insurance providers, financial providers, or general companies interested in quantum to form a kind of ecosystem of what this is what we're doing, what are you doing, pros and cons. Because there's not that many people in the quantum space at the moment, and it's a space that's only going to grow. So I think bringing knowledge together is only a good thing. And we've realized internally just how much interest there is in quantum, because it's quite a fancy buzzword. People hear it and they get quite excited. So I think maybe I think getting the word out there that there is an insurer interested in quantum computing, and if there are others, we can discuss what we're working on and potentially work together in that aspect.
Excellent. So my next to last question is, you know what you're doing internally at AXA, but if you could influence what other vendors are doing, whether software or hardware or other enterprise companies or consulting companies, what would you like them to focus on in the next year or two?
Yeah, so I mentioned a little bit this, right? It's I told you, like I think what's really challenging. I already said, and I will say something else also after that. But the thing is, I really think that the business part of the problem is very important. I mean, if people come and tell me, yes, I can accelerate Monte Carlo sampling from n to square root of n, oh well, that's cool, right? Especially if n is big. But what does it mean this in practice? Okay, for my business, and I think this is a little bit underestimated. The other thing is, I think we're very at early stage technology. I think it's very promising. I'm really enthusiastic. I wasn't initially, to be honest with you. It's by getting deep into this, I really think I'm very enthusiastic about it. And but I think since this is early stage, also the second thing, it's about trust. It's about sharing and working together. And yeah, so one advice is, yeah, when we work with the people we work with is usually the ones which are open to share, and not try to kind of like, oh, we have these secrets and we have these great things but we cannot explain anything. But that they are kind of transparent, because as you saw through the old podcast, really we're about understanding. You need to have the understanding inside the company to make it happen. So if these companies don't transfer in some sense the understanding, it's going to be very difficult to make it happen, because it's a long chain after. Usually the people you're entering is us, but afterwards there is a long chain after us still. So yeah, so it's really about that.
Excellent. How can people get in touch with you to learn more about the work that AXA and you are doing?
Yes, contact me. I'm happy to talk to anyone about quantum computing. You can put my email in the bio, or contact just George Woodman on LinkedIn. And I'd happy to have a chat about anyone that's interested in quantum potentially collaborating.
Perfect. Thank you so much for joining me today.
Thank you to you, and thank you for people listening.
Yes, thank you very much.